all alone, can face it while alone and on, without a clue, without a sign, without grasping it. The real question to be asked: where have I been? I'm a sharpshooter at post masquerade, hiding both face and mind, all free for you to draw. I'm a sharpshooter. What else should I be? Please don't take off my mask, revealing dark. Moments of calm, nothing left to be found. A mirror right in front of me, that's where I found an empty glass, reflecting that's a truth. It's telling words not to be told. I need that mask. I'm a sharpshooter at post masquerade, hiding both face and mind, all free for you to draw. I'm a sharpshooter, chained down to my core. Please don't take off my mask, my place to hide. I can't tell you how to see me, just a cage of bones. There's nothing inside. Will it unleash me, burning down the walls? Is there a way for me to break? I'm a sharpshooter at post masquerade, hiding both face and mind, all free for you to draw. I'm a sharpshooter, have no face to show. Please don't take off my mask, my disguise.
Hi, everybody. All two of you that are here. Welcome back to the last lectures of Chem 140. Let's see, what do we got going on today? I mean, it's the end of whatever it is we're doing, right? So, this. We're going to cover the last section in the text, and then we're going to talk about the lab. I'm going to do a few lab questions to get you started. I'm going to do problems that are similar so that you can just follow what I do, and then you should be able to do the lab. So, for this section, we are going to do content from basically units 13 and 14, where we determined a quantity from another starting quantity using a chemical equation. For this case, now we need to use molarity as a conversion factor to invoke volume. And so the way that that works out is that if you know molarity and you know volume, you know moles, and that gets you onto the chart. So if you remember this chart from before, we can now just add volume to it. And so we're going to do these types of problems again. Instead of just giving you a solid to start with and say, oh, how many grams will this make of this product or whatever, now we can use solutions and calculate the results from there. So let's do an example of that. So let's suppose that I give you this acid-base neutralization. So acid-base neutralizations are very common in chemistry. And when you neutralize an acid, acids have H plus in the front, and a base, most bases have hydroxide, but there are others. The product you get is water. Whoop, there it is. And then whatever else is left over makes your salt that form. So this is a very common reaction. I said water, so I had to take a drink of it. So what we're going to do for this reaction is we're going to react 4.90 grams of phosphoric acid with some volume of 0.250 molar sodium hydroxide. Now, if I don't know what the volume is, I don't know what the number of moles of it is, so I'm going to have to calculate it coming in from the other direction. So, since I know the mass of phosphoric acid, I can work with that and start there. So, that didn't load. Hold on, there we go. So let's get the equation on the screen here. And then we'll try and solve the problem here. So I am given a mass of phosphoric acid. And my end goal is to get a volume of sodium hydroxide. Now, just like before, we're going to do the same thing. We're going to turn everything into moles. Maybe if I make this bigger. I feel like something is weird on my screen here. It feels off. I don't know. Okay. And then I can relate the two together using the balanced chemical equation, which I have shown there. So let's write out the relationships here. So in order to go from mass of phosphoric acid to moles, I would need to know the number of grams in a mole of H3PO4. So we'll get out the Lentech. Where are you, Lentech? Oh, I closed the window. Not Lentect. And I gotta type in... There we go. 98.00. So there are 98.00 grams of phosphoric acid per mole. All right. And then how many moles per how much volume over here? Well, with volume, the relationship is going to be some number of moles per liter, right? And that would be this, 0.250 moles NaOH per liter, because these two things together would be that. Yeah? That's supposed to be an M. Let me make that better. There. And then finally, the middle relationship is just the relationship of the balanced chemical equation coefficients. So 1 mole of phosphoric acid is equal to 3 moles NaOH. And so the calculations we're doing here are exactly like what we were doing in the previous unit. It's just now we have this molarity thing to worry about, which adds an extra step there. So setting up the calculation should be no different than what we were doing. So we'll turn grams of phosphoric acid into moles phosphoric acid. We'll cancel that out. Then we'll do moles of phosphoric acid to moles of sodium hydroxide. And again, we're just following our chart here. Just like we've been doing all quarter with all these conversions. And there we go. Now we can run the numbers. So let's punch all those numbers in. There were 98 grams per mole, so we'll just write that in there. 1 mole phosphoric acid was 3 moles sodium hydroxide, so we'll match up the numbers. And then 0.250 moles per liter. There you go. So now that we've done that, we can punch it in the calculator and we can get our answer. And I got 0.600 liters, or 600 milliliters. Either of those would be acceptable. Now, depending on what Canvas asks you to do, you might have to give your answer in liters or milliliters, so just be mindful of that. If you get liters, liters is what they ask for, then whatever you end up with at the end of the problem will probably be in liters, unless you do a last conversion. If they ask you for milliliters, you will need to do that last conversion from liters to milliliters. So be mindful of that. You don't want to get the problem wrong, get all the way to the end, and then just provide the wrong unit. That would be no good. All right. So now you've seen me do it. I'll have you try this next one on your own here. I'm going to give you a different reaction. This is calcium hydroxide and nitric acid, but these are both solutions. So I want to know what volume of 0.125 molar calcium hydroxide would completely react with 15 milliliters of 0.225 molar nitric acid. So one of these two things you know the number of moles for because you know both the volume and the molarity. Use that to find the moles of the other thing, and then find the volume that is needed. Just like we did before, except instead of starting with a mass, I'm giving you a molarity and a volume. Okay? So I'll give you a few minutes to try this. I realize these are longer problems. And I also realize there's not that many people here. So now there are 5 people. Okay, cool. So somebody will probably finish of the 5 people and actually say something in the chat. So please let me know what your answer is when you have one. All right, see you in a bit. Yeah, if you missed a day, well, I mean, as long as you understand how the units work for molarity and volume, they just cancel each other out when you multiply. Then you're left with moles. You're probably in a good spot, but if you missed all of the molarity discussion, then this one's going to be a little rough. One more minute, we'll go over the answer together. All right, let's go over the answer here. Ah, that's not what I meant to do. There we go. Oh, I misclicked. There we go. All right, so this time we're doing a volume to a volume. So we have volume of something and volume of something else. Now, the problem says what volume of this thing? Calcium hydroxide. So that's going to be where we're going. Where we're starting will be with the other thing, nitric acid. And just like all the previous problems, we're going to turn it into moles. Turn everything into moles. And then turn one into the other. And then we need to look up relationships. Well, I know the molarity, so I know how to relate moles to volume. So for nitric acid, that is 0.225. Oops. Where's the eraser button on my pen? There it is. 0.225 moles per liter. And for calcium hydroxide, that would be 0.125 moles per liter. And then we look at the balanced chemical equation for the relationship between moles of nitric acid and moles of calcium hydroxide. And that's 2 moles nitric acid equals 1 mole calcium hydroxide. And that's from the balanced equation up here that I can't draw on because it's in a different window. I could do it over here. So that's this number that's not written and this 2. All right, so now we can do the equation, or calculation, I should say. And I'm going to react with a volume. So I need to write down the volume to start. Now, milliliters is not going to help us much when we're trying to convert with molarity. So we got to turn this into liters. And 1 milliliter is 10 to the minus 3 liters. So this would be the number of liters of nitric acid being used. So now we can then do our stoichiometry here to do liters to moles of nitric acid. Then we'll turn moles of nitric acid to moles of calcium hydroxide. And I'll go down here to continue. Moles of calcium hydroxide can be turned into a volume of calcium hydroxide in the same way. So now we got all that, we can go in back and do the numbers. So what's the molarity here of nitric acid? Well, it's 0.225 per liter. So that many moles per 1 liter. Then the relationship between nitric acid and calcium hydroxide is 2 to 1. So 2 nitric to 1 calcium hydroxide. And then I need the molarity of calcium hydroxide. How many moles per liter that is. And so we'll just punch in all these numbers, and that'll be my volume in liters, which we can then turn into milliliters. So 15 times 10 to the minus 3 times 0.225 divided by 2 times 0.125. And I got 0.0135 liters, which is 13.5 milliliters. And there you have it. Now, if you don't convert the milliliters to liters, what ends up happening is that this milliliter tries to cancel out with this liter over here. But in reality, what ends up happening is this liter and this liter cancel out, and you're just left with this, which is why your answer still works. So that's fortunate. But just to be on the safe side, I would convert to liters every time. Because if you weren't working with liters as a volume, or if you weren't getting a volume at the end, and you were instead, say, getting a mass, you'd have a mass that was 1,000 times too small. Or 1,000 times too big, actually. But if the units work out, and in this case they do, because you have something on the bottom and something on the top and they would cancel, then you don't even have to really do this step. You'll just get an answer that's already in milliliters for you. Yeah, that's the secret to doing any of these types of problems, is just follow the units. Now, the trick to being able to follow the units is to do like hundreds upon hundreds of thousands of these problems. I've done probably 10,000 stoichiometry problems in my life. Like, every time I teach a class, I do like 50 of them, right? And I certainly did a ton of them when I was in schools. 10,000 is probably way too high, now that I think about that. I've definitely done over 1,000, though. And as you do them more and more and more, you can see where all of your units are just going by just looking at what the units are, and then you just set it up automatically. So that's a sort of skill that you develop as you just do more problems. So this is the part that you missed yesterday. So we defined molarity as some number of moles of solute over the volume of the solution in liters. And so, for example, in this problem right here, this number would imply that there are 0.125 moles of calcium hydroxide per liter of solution. So whatever number is written, that's how many moles there are in 1 liter. Now, you don't have to have 1 liter. For example, if you had this many moles in 2 liters, then the molarity would end up being this. Because 0.25 divided by 2 is 0.125. So with the number as written, then yeah, that is per 1 liter. But you can use molarity for any number of moles in any volume that you want to. All right, so let me give you the last problems here. There we go. So we're going to react hydrochloric acid with iron 3 hydroxide. We're going to use 52 grams of iron 3 hydroxide because it's just a solid that you could just drop in there. What volume of 1.50 molar HCl is needed to react completely with it? And then how much iron 3 chloride will you make when the reaction is done? So one of those questions is a molarity involved problem, but the other one is just a review from the previous chapter. So you should be able to do the second one in a pretty straightforward manner. I'll let you try these. We'll go over the answers, and then after this, we are going to move on to the lab. This is the last slide, so there's no more course content after this. So go ahead and work on this problem, and we'll see you in a bit. 1 or 2 more minutes and we'll go over the answers. All right, let's go over the answer. All right, so we'll just put both of those on there. So first problem, we are given a mass. And we're asked to find a volume of HCl. So, something moles. Always a good first step. And then I can convert one to the other. Now I have a mass to a moles, so that's going to need the molar mass, which means I get to go to Lentech, if I can find the window. There we go. FeOH, parentheses 3. I got 106.87 grams of iron 3 hydroxide is equal to 1 mole of it. Then down here for moles to volume, I'm just going to use the molarity. So 1.50 moles of HCl are in 1 liter. And then finally, the relationship between moles of FeOH3, 1 mole of iron 3 hydroxide reacts with 3 moles of HCl. All right, we got all the relationships. Let's do the reaction. I'm going to react 52 grams of that. We'll turn grams into moles. Then we'll turn moles of... Oops, I forgot my iron there. Moles of iron 3 hydroxide into moles of HCl. And then finally, we'll turn moles of HCl into a volume. And then now we can go and fill in the numbers. So molar mass per mole, we can write that down here, grams per mole. There's 1 mole of iron 3 hydroxide to 3 moles of HCl, so we'll make sure we get the numbers in the right spots. And then finally, the molarity of HCl is 1.50 per 1 liter. And that will give me an answer in liters when I type it in the calculator, which I'm going to do right now. And I get 0.973, which seems to be a popular answer. So it's also the right answer. Very good. All right. How much iron 3 chloride will be made? Well, if I get to this point in the calculation, I could then go over here and just do that, right? So if I get a different color here, I know that that is a 1-to-1 because the balanced chemical equation says so. And then if I look up the molar mass of FeCl3, it's 162.20 grams of that equals 1 mole. So I can do this process. I wrote through all of my stuff, but you get the idea. That's where we're going with this. So we'll do that calculation down here at the bottom. So that looks really bad. Hold on, let me fix that. So again, we'll turn grams of iron 3 hydroxide into moles. Really, I could have just copied and pasted this. And then instead of moles of HCl, we'll just do moles of the other thing that we're looking for. That should be a 3. There you go. All right, now we just fill in the numbers. So this is still 106 point. Let me do the different color here. Oops. Still 106.87, and then this is going to be 1-to-1 now for this relationship. And then this one is 162.20 grams per mole. Let me punch that in the calculator too. 78.9 FeCl3. There you go. That's the mass of it in grams. There you go. All right, so those are all the calculations that you'll need to know how to do to complete the second exam and also the final exam. So what we're going to do is when we get back from the break here, so I'm going to put the break card timer on in just a second here. We're going to come back and talk about the lab and show a few sample calculations and what you're doing. So with that in mind, I will go over to here and hit this button. And we will start the music, Maestro. So I'll see you in a bit. Alright. We'll wind this down here. And we'll go over here, where that already appeared, which is good, I guess. Okay, so let's see here. We don't want this. We do want this one. Alright, so let's talk about the lab a little bit. For worksheet number 5, what you're going to be doing is a series of calculations that involve concepts and content from Unit 16. So there's going to be 2 parts to this. Part A, you're going to show how to make solutions. This is going to involve the dilutions section. And then in part B, you are going to do a titration. And a titration is much more involved. So if you read over this, you can see that, oh, here are the 3 steps that we talked about the other day and how to make solutions. Then we talk a little bit about acid-base chemistry and stuff like that. All right. We'll come back to this picture in just a second. But what I do want to show you is how we're going to dilute our solutions for this part of the experiment. So up here on question 7, I think that that's pretty straightforward. You're going to figure out how much sodium hydroxide you need. You can do that, and you should get a round number. Now, part A, a lot of people get confused on, so we're going to do part A here. I'm sorry, question 8 for part A. We're going to do that. Oops. All right, so I think the easiest way to explain this is just to draw a picture. So here's our vinegar. We buy it from the store. It's got a handle on it. And the molarity of the stock solution is this. Now, what we want to do is we want to dilute it by the dilution factor. And so what that means is that if I wanted to dilute it by a factor of 2, so let's do an example here. So if the dilution factor was 2, oh, the question is covering the drawing. Sorry about that. I don't really know where I can put this. I mean, I could do this, duh. There you go. Now you can read it again. Okay. So you're going to dilute by the dilution factor. So for example, if you were asked to dilute by a factor of 2, then the molarity of the dilute solution should be equal to the molarity of the stock solution divided by 2. So the dilution factor is what you are diluting by. So in other words, this would be 0.8261 divided by 2 moles per liter. Which would be whatever it is. And I'm just going to do the math in my head here. So 4, 1, 3, 0, sure. So that'd be the molarity for dilution factor 2. If I wanted dilution factor 3, 5, 7, or 10, I just replace 2 with the correct number. Okay, so you'll get 4 molarities, and they should all be dilutions. So the molarities you get for each of those solutions with dilution factor 3, 5, 7, and 10 will be smaller than the stock solution that you started with. I believe that that's the only question in part A that people get stuck on, but it is kind of important that you know how to do that, because we're going to use that solution that you're going to make in part B, where we're going to use titration data. So I'm going to put the data on the screen, and then we're going to ignore it for a second. So we'll just go boop, like that. And I'm going to describe what a titration is using drawings and art and stuff like that. So when you titrate, you are reacting 2 substances together in a very controlled fashion. And so the tool that you use to do that is called a buret. A buret is a tall piece of glassware with lots and lots and lots of marks on it. It stands upright, and there's a little stopper at the bottom that you can turn this to allow liquid to flow through it. We put some liquid in there, and it drains downward. Now, the important part about a burette is it starts up here at 0, and it ends down here at 50. So if I started the titration, like right here, the initial volume would be, I don't know, I'm just going to pick a number. And then it would drain down to, say, maybe here. Then the amount that was used would be final minus initial. And that would be, in this case, something like that. So if you are looking at the data table, which we'll put back on the screen here, boop, you'll notice that all of these have final and initial volumes. But it seems really weird that the initial volume would be lower than the final volume unless you realize that this is how the scale is set up. 0 is at the top and it counts down. So be mindful of that. That's how you calculate the volumes. Where do the volumes go? Well, they come out the bottom here, and they go into a flask. And the flask will have whatever it is you're reacting with. There's some words that are used commonly. The stuff in the burette that you are using to do the titration is called the titrant. And the substance that you are using in the flask as the reaction is the analyte. So you put the titrant in the burette and you react it with the analyte. Generally speaking, for an acid-base reaction, we tend to put the base in here for some reason, and then we put the acid down here. I guess so I can say that we can have chemistry dubstep where you drop the base as the drops come out of the burette. Why we specifically do base instead of acid, I don't actually know. In fact, I feel like it should be the opposite, because bases do deteriorate glassware over time. But anyway. Now, when you do this titration, you will determine the volume of base. So this would be the volume of base that was used. If you know the molarity of the base, then you can calculate the number of moles of the base, and then you can do stoichiometry. So, once you know the number of moles of base you have, you can do the calculation. Alternatively, if you were given a volume of this acid, which you should be because you're going to put some volume in there, and you know its molarity, you then know the number of moles of acid and can also do stoichiometry. So for titrations, one of the two things is going to give you the information that you need to solve the problem. The other thing is what you're going to have to calculate. So let's look at the titration. I'm going to have you try and calculate do one of the calculations here. I got to call it back up here. There we go. All right, so the first trial that we're doing in here, according to the directions, it says we are using an unknown concentration of sodium hydroxide and a known concentration and volume of sulfuric acid. So one of those two substances you have enough information to determine moles for. And that information is all presented in this data table here. So what you need to do is you need to find the number of moles for the thing you know, and then do the stoichiometry. Turn moles of that into moles of the other thing. And then figure out the quantity that's needed. In this case, since the concentration is unknown, we're solving for the concentration of sodium hydroxide in this first part. And it's shown here how to do that. So first, tell me the number of moles of the first thing. Tell me the number of moles of sodium hydroxide. Then calculate the molarity for each trial and then the average molarity. So we're going to do trial 1 just to show you how to do that. I do not wish to delete my scene. No, thank you. I almost erased everything in OBS. That would be bad. All right, so I don't want to start with moles. I want to start with volume of H2SO4. I don't have that much space to work with, unfortunately, here. So my goal is to get from volume H2SO4. Eventually, I need to get to molarity. Of sodium hydroxide. Now, we haven't done a problem where we solve for the molarity of sodium hydroxide, but it turns out it's not that difficult. What we need to do is we would need to know the number of moles of sodium hydroxide and the volume of sodium hydroxide, right? Well, I can get this from doing the calculation of turning this into moles. And this just comes from the titration. In fact, you already know the number of volume of sodium hydroxide. It's right there in the chart, right? So now we know how to solve this type of problem. So we'll find the number of moles of sulfuric acid. So that would be 0.0750 moles of sulfuric acid per liter. And of course, it's time to leaf blow right outside my window. We're going to multiply that by the volume that was used, which was 25 milliliters. Now, those won't cancel out, so I'm going to need to do this. So this cancels with that, and this cancels with that. And there's 10 to the minus 3 liters per milliliter. So this would tell me the number of moles of sulfuric acid in the solution. All right, that's the first step. So we just did this calculation right here. Now to figure out this part, we need the balanced chemical equation. Now, part of the lab is for you to figure that out based on the description. So, if you're reacting this and this, what are the results? You're going to have to write out the balanced chemical equation based on the lab documentation. But you're going to get some numbers that go in front of here once you balance the equation. And then what you do is you take this number of moles of this and you just say, okay, well, if I have this many moles of sulfuric acid, I can then do mole H2SO4, mole NaOH to get to this part of the calculation. And then you just put the numbers right in the calculation where they should go, right? Because these units would then cancel out, and you'd have moles of sodium hydroxide. Then what you need to do is, once you know the number of moles of sodium hydroxide, I'm just going to call it X, to get molarity, you just divide by the titration volume. And it's got to be in liters. So that's going to come from the table up above. What was the volume that we used in liters? Well, it was 15.78 divided by, or not divided by, minus 0.20, right? So putting those two numbers together will then give you the molarity of sodium hydroxide. All right, so that's how you do the problem without me doing all the questions for you. Now, later on in the lab, you're going to do the same thing with vinegar, except in the vinegar case, the molarity of the vinegar will be assumed to be unknown, and the sodium hydroxide will be known in that case. So when you scroll down to this next titration table, right here, you're going to be using your answer for sodium hydroxide from the first part, and you're going to use that to determine the molarity of vinegar shown in the table based on this titration data. And then finally what you'll do is you're going to look at the number that you generated for the result, and you're going to compare it to what the answer is that you expected back in question 8b when you calculated that dilution factor. Specifically, the vinegar that is used in this titration, I believe, is dilution factor 5. I'm trying to find where it says that. Yeah, there it is right there, number 4. There's supposed to be an enter carriage return here, but so for the vinegar, you're going to be using dilution factor 5 vinegar. So whatever your answer was for 8b, that's the expected result, but we're going to assume that it is unknown in this table, which is why there's no number here, okay? You're going to calculate this number, not just write it in. All right, and then the rest of the questions are just titration questions, just like you did. Now, I realize that this is the last lab, and that there's very little time to do this and a quiz and an exam and a final. So, more or less, when I assign this worksheet at the end of the quarter, I just want you to do this as practice for the exams. So I'm really just going to be grading this very, very loosely. When I get it next week, I'm just going to look to see if your numbers are close and that you tried it, okay? So do the best that you can. But that's really all I have to say about the worksheet. And that's also why I go through all of these steps before we do that. So I keep selecting the wrong thing. No, I do not want to delete all of my scene. There we go. The last thing I want to do before we adjourn for the quarter is, so first of all, we have to celebrate because congratulations, that is the end of Chem 140. Hooray! Yay! We're all super excited for that. I mean, at least I am, so. And that's what we're going to talk about now. So we need to get all of the administrivia out in the open so that we know what's going on. So let's talk about week 10. So today is Thursday. And what day is today? Today is Thursday, the 11th. So you are here. Unless you are not here, in which case, hello from the past. I had changed it up at the end, right? All right, so what is going to be due upcoming? Okay, so first of all, there's kind of this special instance with the quiz. So quiz, and I don't know what number quiz we're on, but it's units 15 to 16. So the last quiz, I realize you have way too much shit going on and way too little time to do it. So what I do is I set this to have no deadline and open answers. And it's worth 1 point. And if you do it, you get a point. Basically, what I do is I look in Canvas and I see, oh, did they attempt to do the quiz? You get 1 point. I do not lock the answer key after the quiz. This is merely for practice, okay? So the last quiz will not have a deadline. I'm going to open it right after class is over. And you can take it whenever you want to, whenever you feel ready. And you still only get 2 attempts. I can't give you infinite attempts, obviously. But when you take the quiz, it will immediately show you what your score was on it out of 10, because they're all programmed to be 10-point quizzes. It will also show you the answers, and then you can ask me any questions about those questions that you want to on days that are not the exam or the final. Okay, so that will be available. And you should take that before you take the exam, obviously, just so you can see those types of questions. The next thing that we have to talk about, so lab worksheet number 4 is due today. That's the soft deadline. And last call for it is tomorrow. So make sure that you get that lab worksheet number 4 in. Again, that's more practice for these units at the end. And that's everything for week 10. So let's go forward to finals week. So on Monday, which is the, I don't know, 17th? No, 15th. So Monday, 15 March, exam number 2 happens. Just like the first exam, the exam will be open all day. You can take it at any point during that day that you would like. I'm going to scroll this down a little bit because I need more space. You get 2 attempts. Your score will not be posted until all the exams are in, so you may have to wait a day or 2. And I do not reveal the answer keys to exams. Excuse me. So there's that. Tuesday, nothing goes on. Tuesday may be an exam day for some people if they need to. So remember, you can email me and ask, like, hey, I need to move the exam forward or backward one day because I have other exams or finals or whatever. Totally okay with that. You take the exam on Sunday or Tuesday. You just have to email me and let me know which. Don't do it the day of the exam. If you need advance accommodation, they have to be in advance. If you email me that day and say, I need more time, can I take it tomorrow? I may not be able to accommodate that depending on when you ask me. If you ask me at 10 p.m., I certainly cannot do that. It's too late. Okay? Please ask me in advance as you can. On Wednesday, here from 2:30 to 4:30 p.m. is a review. And on the review day, I'm going to review any material that you want to from any chapter or anything at all. You can ask me any questions, okay? It's just totally for your benefit to prepare for the final. And the final exam is going to be a very slight modification from the syllabus. I'm going to have the final exam open on the 18th and the 19th. So that you have 2 days to do it. And as long as you get your final exam done on one of those 2 days, it will be credited to your account and you will get whatever your score is on the final. I realize that a 2-hour final is long, and taking 2 of those in a day, probably not super great. So I've started giving you 2 days to do the final. You can do it at any point during those 2 days. It doesn't matter to me. This one I cannot change the dates on, okay? So I cannot let you take the final later than Friday. You have to have it done by Friday. So this is the last call. Exams and final, you get 2 attempts still. So you can take the final twice if you'd like. It will not show you your score. So you have to go on your gut, like, oh, I feel like I did really well. I don't need to take that a second time. Or if you aren't sure, just take it twice, right? Like, why leave the opportunity on the table if you have no idea how well you did? But most people can get a good idea of, like, yeah, I did pretty good on that. All right. Lab worksheet number 5. Is due, and I have to go look this up because it is in the syllabus, and I just want to match what the syllabus says here. So let me dig around in folders here to find it. There it is. It's due Friday. Okay. All right. And that deadline is actually going to be a hard deadline because I need all NQA and stuff must be in by Friday. Friday the 19th. Okay, so anything that is left in the course, I need to have it by Friday. Okay. On Saturday, I will then download everything to my Excel sheet and program all of the stuff into my gradebook. I will then assign your final grades once I've graded everything else. Okay, so I cannot accept anything after Friday. If you don't get it into me or send me an email, it's got to be time-stamped before Saturday for me to accept it. When will Quiz 8 post scores? I don't know what the number for Quiz 8 is. Is that Unit 15? Let me look this up real quick. Quiz 8 closed yesterday, so I need to hit the button so that it will post scores, but I'm going to do that after class. I'm going to then go and program in all these deadlines and due dates. And so it'll all be set up. Things will open when they should. And all that will be for me to do is to hit a button to post grades. So yeah, it is units 13 through 14. And I will hit the button after the stream is over because we're done here. This is everything you need to know. So it's all on the screen. I'm going to zoom this out a little bit so it'll fit. There you go. That's it. That is everything that you need for the last week and change. All right. Once again, congratulations on finishing the class. Like, I mean, you still have stuff to do, but that is all the content that I have prepared for Chem 140. So I want to thank everybody for not just coming out to the lecture today, but for being in attendance, for sending me questions either through Discord or email, just generally talking to me. I know there were times where, like, when I really screwed up my back, that a lot of people send me emails of support, and I really appreciated that. Thank you. My back still hurts. Like, what the hell? I'm gonna have to actually go to a doctor. But yeah, so thanks for making this class enjoyable. I hope that you got something out of it, and I hope that it will provide you the foundation that you need for Chem 161, which I am teaching next quarter. So for now, it is a brief goodbye, excluding the review session, which we will see on Wednesday. But then we'll have 2 weeks off, and then once again we will reconvene for 161. So take care, and I hope that you have a wonderful finals and spring break. So I will see you when our paths once more cross. Take care, and I'll see you then.